Everyone, today we are going to study singular value decomposition. Singular value decomposition. Okay. So what does mean by singular value decomposition? We are having one matrix A. So that matrix A is decomposed into product of three matrices. Namely, one is U, another one is sigma, and next one is V transpose. So this A is decomposed as product of these three matrices. Here A is nothing but one M by N matrix. So order of A is M by N. It has M rows and N columns. Okay. And U is an M cross M. So this is one square matrix. U is a square matrix. M cross M, orthogonal matrix. With columns equal to the unit eigenvectors of unit eigenvectors of which matrix? A transpose. Okay. So we have to find A transpose. For that A transpose, we have to choose the characteristic equation eigenvalues, eigenvectors. For that, we have to write the union eigenvectors, unit eigenvectors. And these unit eigenvectors are taken as column vectors. So if we do all those things, we get one new matrix. It is known as our U. Okay. And V is an N cross N. So this is also one square matrix. So N cross N orthogonal matrix with the column equal to the unit eigenvectors. Eigenvectors of A transpose A. So we are finding A transpose A first. For that, we are finding characteristic equation, eigenvalues, eigenvectors, unit eigenvectors, and the V matrix is represented as column vectors are taken as unit eigenvectors. So with this, we are creating V matrix. So for that we are writing V transpose. Next, we should know what is our sigma matrix. So for that, so to obtain sigma matrix, we should know the singular values. So the singular values of A are the square roots of the positive eigenvalues. Note the point, we may have negative, 0, all those things we don't want. We want only a positive eigenvalues. For that, we have to take the square roots. Square root of the positive eigenvalues of A transpose A, otherwise A transpose A. So both the matrices have same eigenvalues. Among that, we have to choose the positive eigenvalues. So for that, to find the square root, and those values are known as singular values. So now I am defining sigma. So what is that sigma? So sigma is nothing but an M cross N. So the sigma is order of our given matrix. M cross N matrix with the singular values. So previously we calculated singular values, no? So those values we have to take into account with the singular values of A on the main diagonal. On the main diagonal. And all other entries are 0. Okay, so with this, we can find sigma. So if we find product of U sigma V transpose, we will get our capital A. So the given matrix is decomposed using singular value. So the name is given as a singular value decomposition. So again, we should find 3 type of matrices. One is U, V, and another one is sigma. U is one square matrix whose order is M. It is one orthogonal matrix whose columns are taken as unit eigenvectors of A transpose. And V is also one square matrix whose order is n, which is a orthogonal matrix whose columns are unit eigenvectors of A transpose A. And sigma is one m cross n matrix. We have to choose singular values on the main diagonal, and remaining entries are taken as 0. So singular values are obtained as the square root of positive eigenvalues of A transpose A, otherwise A transpose, so sorry, I wrote here, A transpose. Okay, so both A transpose A and A transpose have the same eigenvalues only. Among that, we have to choose the positive and take the square root. We get singular values. So with that, we can decompose our A as singular value decomposition. So we will see one problem in this category. Okay, so your problem is decompose A equal to matrix 1 minus 1 3 3 1 1 as singular value decomposition. So here the given matrices of order 2 by 3. Okay, so A is of a solution. A is of order 2 rows. It has 2 rows and 3 columns. So it is a 2 by 3 matrix. So I am going to write A as a product of 3 matrices. So first we will deal with V and then U and then sigma. Okay. So to get our V matrix, we need A transpose. So write a solution. So it is given A equal to 1 minus 1, 3, 3, 1, 1. Okay. So from that I am writing A transpose. So what is my A transpose? It is 1, 3, minus 1, 1. Third column is third row. So it is 3, 1. So this is our A transpose. So we know V is nothing but one n cross n orthogonal matrix whose columns are taken as unit eigenvectors for the matrix A transpose A. So we want A transpose A eigenvalues, eigenvectors and so on. So first we should know A transpose A. So A transpose A, that is product of 1, 3, minus 1, 1, 3, 1 with A, which is 1, minus 1, 3, 3, 1, 1. So we are going to find product. So multiplying first row by first column. and first row by second column, first row by third column, we get first row of product matrix. So the product will be 1 into 1, so it is 1 plus 3 times 3, so it is 9. And in second column product value will be 1 minus 1 is minus 1. 3 times 1 is 3. 1 times 3 is 3 plus 3 times 1 is 1. So it is 3. And taking second row, it is minus 1 plus 3, 1 plus 1 minus 3 plus 1. And then multiplying third row with the first column, we get first entry of third row of product matrix, which is 3 times 1. So it is 3. 1 times 3, it is 3. And minus 1 plus 1, 9 plus 1. So the product is A transpose A is like this. So if we add, it is 10, 2, 6, 2, 2, minus 2, 6, minus 2, 10. So this is our A transpose A. So for this, we need eigenvalues, eigenvectors. So for this A transpose A, I am going to write the characteristic equation. So it is here. So A is of order 2 by 3. So N is 3. So we get A transpose A is 1, 3 by 3 matrix. Okay. So since order is 3, characteristic equation is 1 cubic equation. So characteristic equation is lambda cube minus S1 lambda squared plus S2 lambda minus S3 equal to 0. Where S1 equal to trace of the matrix, that is the sum of diagonal. So it is a trace of A transpose A. So for this matrix only we are finding eigenvalues. So which is 10 trace is nothing but a sum of diagonal elements. So it is 10 plus 2 plus 10. So all these are diagonal elements. So addition of these will be 22. And S2 equal to sum of minus of main diagonal elements. So for main diagonal element, we have to write the minus and find the total. Okay. So all these we studied in previous chapter. So now we are utilizing all those. So minor of first diagonal element 10 will be 2 minus 2 minus 2, 10. And minor of diagonal element 2 will be deleting second row and second column. We have 10, 6, 6, 10. And minor of next diagonal element, that is 10. Minor of 10 will be deleting third row and third column. We have 10, 2, 2, 2. Okay. So if we expand, we get this is 20 minus 4 plus 100 minus 36 plus 20 minus 4. So it is 16 plus 64 plus 16. So totally this value will be 96. And S3 is determinant of that one. That is A transpose A. So for that only we are finding our eigenvalue. So it is determinant of 10, 2, 6, 2, 2, minus 2, 6, minus 2, 10. So finding determinant, that is we are expanding along first row. So we are having 10 into, it is 20 minus 4 minus 2 times deleting first row and second column. It is 20 plus 12. And plus 6 times deleting third column and first row, we are having minus 4 minus 12. Okay, so this is 10 times 16 minus 2 times 32 plus 6 times minus 16. So 10 times 16 is 160 minus 64 minus this is 96. So it is 160 minus 160. So the total will be 0. Therefore, our characteristic equation is lambda cube minus S1. S1 is 22. So it is 22 lambda squared plus S2. S2 is 96. So 96 lambda minus S4, sorry, S3, which is 0. So we can take lambda outside. So it is lambda squared minus 22 lambda plus 96 equal to 0. So product of two terms is 0. So either first term 0 or second term, that is lambda squared minus 22 lambda plus 96 equal to 0. So this is one quadratic equation. So product we want 96 and the sum we want minus 22. So the numbers are minus 16 minus 6. So if we multiply minus 16 and minus 6, we get plus 96. Adding, we get minus 22. So the values of lambda are lambda is 0 or lambda minus 16, lambda minus 6 equal to 0. So from this, eigenvalues are 0, 16, and then 6. So these are all eigenvalues. Next, our main aim is to find the eigenvector because that V is nothing but one n cross n orthogonal matrix whose columns are taken as unit eigenvectors of A transpose A. So we need eigenvectors. So to find eigenvectors, so to find eigenvectors, so we know eigenvector calculation is A minus lambda I x equal to 0. So putting x is one 3 by 3 column, sorry, one column vector consisting of 3 entries. So we get it is so we have A minus lambda I. So it is 10 minus lambda and then 2, 6, 2, 2 minus lambda minus 2, 6 minus 2, 10 minus lambda. So this is our A minus lambda I value. And X is one column vector. Since it is a 3 by 3 matrix, we are choosing 3 rows. So X1, X2, X3. So that is our X, which is null matrix. So 0. So multiplying these two, we get it as 10 minus lambda x1 plus 2x2 plus 6x3 equal to 0. The null matrix is nothing but it is one column matrix. And second entry will be 2x1 plus 2 minus lambda times x2 minus 2 times x3 is 0. And 6x1 minus 2 times x2 plus 10 minus lambda times x3 equal to 0. So one by one we will calculate. So when lambda equal to 16. So here we are putting the eigenvector in descending order. So first we have to choose the largest and then next term, next to smallest like that. So when lambda equal to 16, so we are going to find eigenvector corresponding to eigenvalue 16. So it is 10 minus 16, it is minus 6x1 plus 2x2 plus 6x3 equal to 0. 2x1 plus 2 minus 16, so it is minus 14x2 minus 2x3 equal to 0. 6x1 minus 2x2 minus 6x3 equal to 0. First and third are same equations. So we are going to apply cross multiplication rule by using first and second equation. Before that, we will simplify this one into smaller format. So it is minus 3x1 plus x2 plus 3x3 equal to 0. And second one will be x1 minus 7x2 minus x3 equal to 0. Now to apply cross multiplication rule, start from second coefficient and end with the second coefficient. So it is 1, 3, minus 3, 1, minus 7, minus 1, 1, minus 7. So by applying, we get it is x1 by minus 1 plus 21 equal to x2 by it is 3 minus 3, and the x3 is 21 minus 1. So we get x1 is, so this vector is denoted by x1. So it is 20, 0 and 20. So dividing throughout by 20, we get x1 is 1, 0, 1. So this is our x1. So we need a unit eigenvector. So for that, we should find the length. So what is length of this eigenvector? It is nothing but a square root of square values of each entries. So it is 1 squared plus 0 squared plus 1 squared. So it is root 2. So dividing length by each of the eigenvector, we get unit eigenvector or normalized eigenvector. Okay, anything we can get. So it is unit eigenvector, which is 1 by root 2. 0 divided by root 2 will be 0 and 1 by root 2. So this is our first column for our given matrix. Okay, so first we have to take the eigenvector corresponding to the largest eigenvalue. Next, succeeding terms we have to consider. So we should concentrate on this. So it's very important. So next term I am going to consider is here 6. Okay, so 16 first eigen, and then next 6 afterwards 0. We are write our eigenvalues in descending order according that we are finding. Okay, in that order only we have to make column vectors to find V. So when lambda is 6, so lambda 6 we are putting in this, it is 10 minus lambda is 4x1 plus 2x2 plus 6x3 equal to 0. 2x1 minus 4x2 minus 2x3 equal to 0. 6x1 minus 2x2 plus 4x3 equal to 0. Now simplifying first and second, we will get it as 2x1 plus x2 plus 3x3 equal to 0. x1 minus 2x2 minus x3 equal to 0. So writing coefficients, it is 1, 3, 2, 1. Minus 2, minus 1, 1, minus 2. So applying cross multiplication rule, it is x1 by minus 1 plus 6. x2 by, it is 3 plus 2. x3 by -4, -1. So it is x1 by 5, x2 by 5, and x3 by -5. So throughout we can divide by 5. So our next eigenvector is x2, which is 1, 1, -1. Okay. So now I am finding unit eigenvector. For that we need the length. So length is square of each value. So it is 1 squared plus 1 squared plus 1 squared. For that to take the root. So it is √3. So dividing each eigenvector by this length, we get unit eigenvector. So unit eigenvector is, it is 1 by √3, 1 by √3 minus 1 by √3. So this is our second column. And then third column is eigenvector corresponding to lambda is 0. So when lambda is 0, we get it as 10x1 plus 2x2 plus 6x3 equal to 0. 2x1 plus 2x2 minus 2x3 equal to 0. 6x1 minus 2x2 plus 10x3 equal to 0. So I am going to use first and second. So for that I am writing the simplified form. So it is 5x1 plus x2 plus 3x3 equal to 0. x1 plus x2 minus x3 equal to 0. Now, starting from second coefficient and ending with the second coefficient, we get it as 1, 3, 5, 1. 1 minus 1, 1, 1. Applying cross multiplication rule, it is 1 x1 by taking first two columns and finding determinant, we get -1, -3. So x2, second and third. So it is 3 plus 5, x3, 5 minus 4. So it is x1 by -4, x2 by 8, x3 by 5 minus 1, this one. So it is 4. So dividing throughout by 4, we get our x3 will be -1, 2, and then 1. So length of eigenvector is -1 squared plus 2 squared plus 1 squared. So it is 6. So it is √6. So unit eigenvector. So the unit eigenvector is denoted by x3. So x3 will be, it is -1 by √6, 2 by √6, 1 by √6. So by choosing all these eigenvectors as columns, we are going to find the matrix V. So V is, so first column vector we know, which is 1 by √2, 1 by √2, 0, 1 by √2. And second column is 1 by √3, 1 by √3, minus 1 by √3. Third column is 1 minus 1 by √6, 2 by √6, 1 by √6. Okay. So this is our B matrix. So still we completed only half part. Still we have to proceed further. Next, we are going to find U matrix. So for that, we need eigenvalues for A transpose. Okay. So I am going to find A transpose to find matrix U. Okay. So what is A? A is 1 minus 1, 3, 3, 1, 1. And A transpose is 1, 3 minus 1, 1, 3, 1. And multiplying these two, we get it is 1 plus 1 plus 9. And multiplying first row with the second column, we get it is 3 minus 1 plus 3. And it is 3 minus 1 plus 3, 9 plus 1 plus 1. So it is 11. And 6 minus 1, 5, 5, and this is 11. So it is a 2 by 2 matrix. We know U is an M cross M matrix. Okay, here M is 2. So I get it is 1 2 by 2 matrix. So for this 2 by 2, we need eigen value. So since it is a 2 by 2, our eigen value formatting is writing characteristic equation, which is a quadratic equation. So we are going to characteristic equation is lambda squared minus S1 lambda plus S2 equal to 0. So S1 equal to trace of that A transpose. So trace is nothing but sum of diagonal. So sum of diagonal elements are 11 plus 11. So it is 22. And S2 equal to determinant of A transpose. So it is 11, 5, 5, 11. So for that determinant we are going to find. So it is 121 minus 25. So the total will be 96. Therefore, characteristic equation is lambda squared minus 22 lambda plus 96 equal to 0. So previously we know the factors are lambda minus 16, lambda minus 6 equal to 0. So product of two terms is 0. So lambda is 16 or lambda equal to 6. So here the positive eigenvalues in previous also we get this 16 and 6. So for this A transpose also we get a same. Okay. So eigenvalues are same. Positive eigenvalues are here 16 and 6.